Okay, so let's try example 1 now. So example 1 says in circle S, arc PR, so this entire arc is 98. So that entire arc is 98. Find the measure of arc PQ. All right, so this is 98 degrees, and we need to find the measure of arc PQ. All right, so I'm going to just really talk through this pretty much as thoroughly as I can. So in this theorem, 10.3, all right, it was told to us that if a diameter or a radius is perpendicular to a chord, then it bisects the chord in its arc, okay? So what I see here is that this radius is perpendicular to this chord right here, which means then that this segment of PT has to be congruent to this segment of TR. And then this arc of QR has to be congruent to this arc of PQ. So if the full arc is 98, then when we divide it, we get 49. All right, so then the arc measure of PQ is equal to 49. So we just cut that 98 in half, all right, because it's split into congruent arcs. Okay, let's try example 2 now. All right, so example 2 has a little bit more depth to it. So it says, use the figure below to answer the following questions. And what I want you to focus on, they're a little hidden right here, but we're looking at, this is an X and Y right here are variables, okay? So it says here if X is equal to 5. So if we know X is equal to 5, which two chords are congruent, okay? So we're going to use the same theorem that we talked about on our last example, where if we have that this radius right here is perpendicular to this chord right here, then what we know is that radius bisects that chord, which means that if this segment right here is 5, then this segment right here is also 5, which means the full length of AB is 10. And so the question is asking us which two chords are congruent. Well, I'm also seeing right here that EF is also 10. So I know that chord EF is congruent to chord AB. I think it's AB. Yep. Okay, so now it says using part A, what is the measure of arc AB? So now we're looking at this full arc right here. So I'm looking at this arc AB. And so if EF and AB are congruent, then we know that their arcs also have to be congruent, which means that the measure of arc AB also has to be 1/16. Now, part C then says, what is the value of Y? Explain your reasoning. So, again, we have this theorem that says that if this radius of OZ bisects or is perpendicular to AB, then it bisects the chord and its corresponding arc. So what we know then is that this arc is congruent to this arc, which means that if we take the 1/16 and divide it by 2, that's going to give us the value of Y, which means that Y is equal to 58 degrees. Okay, now we're going to do example 3, and then from there, the rest of this is just kind of practice, and we'll still go through this, but to do example 3, the best way to do it is, I think this picture is a little blurry, so what I'm going to do is I'm actually going to redraw it, okay? So I'm going to redraw this picture and just really highlight what I'm looking at. So I'm going to go ahead and draw my circle. I'm going to mark my center. And I'm going to draw in my diameter. Okay, so let's go ahead and get some points here. All right, so this top point is G. The circle is J. And then this down here, all the way down here is H. But then we also have this chord that's coming straight across. And this is K. The intersection point is L. And then this is M. And this is perpendicular. So that's our picture here, okay? So it says, in the stained glass window, diameter GH is 30 inches long, and chord KM is 11 inches long. We need to find JL. So this is what we're looking for right here. Okay. So there's a trick to this, but let's just go ahead and talk about the fact that if we know that chord KM is 22, all right, and we know that the radius is perpendicular to KM, what we know is that these two segments right here have to be congruent. So if all of KM is 22, all right, then KL and LM are both 11. And I'm just going to highlight that so I can see that in there. So the trick here, and I typically, when we're in class, I like students to try to figure this out on their own, all right? But the key here is to see how can we use a radius, all right, to help us to find JL. So here's what I know, is I know that the diameter is 30 inches long, which means that the radius is 15, all right? Which means that JH is 15 as well. But we don't want JH, we want JL. So the key here is to see how can you draw in another radius that would help us to find JL. And so what I'm going to draw in is this segment right here. I'm going to do it in pink. Because that pink segment is still a radius. It's connecting a point to the center. And so if we know that the radius is 15, then we know that this segment is also 15. And so if we conveniently now look, though, at this right triangle, we have two of those sides already given to us. And what we're trying to find is JL, all right, which is our task. So what I'm going to do now is I let JL be x, and now we need to solve for x. So I'm going to use Pythagorean theorem. So I'm going to do x squared plus 11 squared equals 15 squared. I'm going to do x squared plus 121 equals 225. I'm now going to subtract 225 minus 121, and I'm going to get 104. So I have x squared is equal to 104. And this says just to find JL, all right? So it's not telling you to put in decimal form or anything like that. So I'm going to keep it in radical form. So I'm going to have x is equal to the square root of 104. Now, we should keep simplifying that, all right? So 104 breaks down into 2 times 52. All right, 52 breaks down into 2 times 26. And 26 breaks down into 2 times 13. And so looking for my doubles, all right, I have 2 square roots of 26 as my final answer. So JL is equal to 2 times the square root of 26. Okay, so those are the big concepts. I'm going to come back here and do the we try or the you try as well, because